Hello everyone, my name is Maria Eduarda Silva Vieira. I'm a graduate from Universidade Federal do Ceará in Brazil, and today I'm going to present to you our study on the enhancement of continuous integration workflows, end-to-end testing with end-to-end testing automation with Cypress. First, I'm going to give you a brief introduction on the subject, including the research questions and the expected contributions. Then, a brief summary on the related work mentioned on the paper. Then, the methodology that was used, then the results, and some points of discussion. Finally, some considerations taken from the paper. Agile is an iterative approach emphasizing adaptability and efficiency. Each iteration includes requirement analysis, design, coding, and testing. Continuous integration ensures frequent deployment and fast feedback cycles. Cypress simplifies writing, running, and debugging tests. And unlike any traditional tool, Cypress interacts, unlike traditional tools, Cypress interacts directly with the browser using DOM events. The goal of this work is to answer two research questions. The first one being, how does using the page object model pattern in Cypress impact test maintainability and scalability? And the second one being, what are the main challenges and the best practices when using Cypress in large-scale agile projects? As contribution of this work, we expect to provide practical guidelines for structuring Cypress tests to facilitate CI/CD integration for continuous validation, and to support developers, testers, and researchers with real-world insights. The researchers selected 10 works that relate to this one. Some that we'd like to emphasize are B. Manapati's evaluation of Cypress and Jai Osna exploration of the use of Cypress in CI/CD pipelines. Our subject system is a web-based medium-sized system in its third year of development. The front end is majorly composed by JSX files, while the back end is a Spring Boot codebase. The project team counts on 24 members and employs agile practices, relying strongly on direct communication with the clients. Test cases are identified through manual testing and discussions with the client and the requirements team. They are documented in Google Sheets for tracking and analysis. A test case is selected for automation if the system must be blocked if the test fails, or the system must not allow certain actions. Um, Additionally, automation can include component checks and UI validation if this is prioritized by the clients. The project has a structure based on the page object model design pattern, separating elements on levels to make the code readable and flexible, and it's divided in three layers of code, being them the elements, the page objects, and the test cases. So the elements directory contains files that store selectors for components used in test cases such as buttons, inputs, labels, etc. You can see a brief code snippet um, selecting a specific placeholder for an element. The page objects directory contains files that have the methods describing the actions that Cypress will perform and the flows to complete a task. In this case, we have a get action, then a waiting period, then another get. We have a get action, then typing a value, then waiting for 1 second, and then getting another element and then clicking on it. The test cases directory contains the files that Cypress will run. The .ci.js files can become lengthy and complex to read with many test cases, and by using page objects, we can significantly simplify these test cases. In this case, this is the test case that will be run by Cypress, and it's calling um, methods that are present in the page object files. So the tools necessary that were needed for developing this test framework were Cypress, obviously. We used Visual Studio Code as an IDE. We use GitLab, Jira, and Google Drive as the rest of the team. The entire team uses these three tools, but specifically GitLab is an important part of the framework, as I will explain now. Um, in the CI process, the development and testing occur simultaneously. As developers work and update the status of new system functionalities in Jira, testers create automated tests to ensure that integration and interface tests pass successfully. The pipeline configuration managed in GitLab CI/CD uses variables to control the execution of jobs. This allows the same configuration to be applied in different test scenarios, such as integration or interface, and simplifies the maintenance. If all tests pass, a pull request is initiated for the test repository, and the merge from the develop branch to the master branch is performed. After the merge, 14 E2E test files are executed to validate specific system functionalities. Failures during the build process are part of quality monitoring, and they help identify and solve issues continuously. As in the test code and in the project product. These are some practice of quality control that we use. The automated tests are created after the development of a feature or the start of the development of a feature, test case registration, and an initial round of manual testing. So we will test manually first, and then we will automate for retesting. We wait for new features to stabilize at least a little bit before automating tests to avoid unnecessary rework and effort from the test team. And regular updates, we make regular updates to the test code alongside product changes to keep the test effective and reduce the effort needed for maintenance. Starting with our results, the test team identified and implemented 155 end-to-end test cases, and they are divided amongst 12 test case files, with the execution time in the pipeline of approximately 13 minutes. Figure 1 offers a detailed presentation of the file contents. It highlights that some files contain repeated test cases. For example, every one of these files contain at least one logging test case. Um, they usually test some interface components to make sure they are there and there is design consistency. We test search and filters. We create dependencies in some cases. You can see it all on this figure. So, the main challenges and the main lessons learned from them involve wait times and maintenance. Regarding wait times, for tests that don't involve performance requirements, synchronizing wait times to ensure components fully load before tests proceed is a very complex task. Another challenge is to integrate automated tests into the CI/CD pipeline which requires careful management of wait times to avoid slowing the execution. And about the maintenance, maintaining automated tests is a challenging aspect of any agile environment, with the constant changes to the product, to the requirements, to the team. The system size and the number of rules must also be considered, as well as the management of these dependencies. As our final considerations, the proposed methodology led to a testing framework that meets the project's requirements and the necessities and enhances test coverage. The Cypress tool proved to be intuitive and integrates well with GitLab CI/CD, supporting maintainable quality assurance. Adopt Third of all, adopting the page object model facilitated organized and scalable test automation, contributing to the project's growth and continuous improvement. So these are the answers to our um, research questions. Regarding the first research question, the page object model improved test maintainability by reducing code duplication and enhancing modularity, making updates easier with interface changes and supporting scalable test suite expansion. And regarding the second research question. The key challenges included synchronizing wait times, managing dependencies, and maintaining tests in a dynamic and agile environment. And also, the best practices are the ones that we mentioned before as quality control practices for our code. In future work, we aim to investigate test mails and their impact on the effectiveness and maintainability of our testing framework. We will analyze how other design patterns, similar to the page object model, contribute to test organization and scalability. Additionally, we plan to extend the methodology to include integration tests and explore performance and end-to-end testing strategies. Our goal is to refine and replicate this approach in other projects to establish a standardized, scalable, and efficient testing framework. These are those are some of our references, and that's it. Thank you very much for your attention.